Okay, so today we're going to look at how to find the equation of a line when we are given a line on a graph. So the first thing we're going to look at is the gradient. So in order to find the equation of a line, you need to be able to find the gradient and also identify the y-intercept. So we'll look at the gradient first. It's the harder part. So what is the gradient? It's the slope or steepness of a line. So imagine a very steep hill that's going to have quite a sharp or a high number gradient, whereas a very shallow incline will be a very mild or small gradient. So the way that we can measure a gradient is imagine that this red line is my line. We can draw a right angled triangle with the part of the line as the hypotenuse. So let's say we drew in here and drew in here. And the gradient is going to be the distance measured up. So from this point to this point is going up by 2. You can see that, divided by the distance measured across. So the y difference divided by the x difference. So this is quite a shallow gradient. It's 2/4. So that would be 2/4, which simplifies to a half. So the gradient for this line is half. Okay, let's look at some examples. So these are all just random disembodied lines. We're not going to find the equation of the whole line for these. We're just going to practice finding the gradient. Now it's really important that you pick points that are on those unit boundaries, so where the two lines of the graph paper cross. And that's because it's a lot easier to divide integer numbers, which is what it will give us, instead of picking random points and then having to divide decimals, ugly numbers, yeah. So here, look, you can see the lines cross. I'm going to pick this point. We'll start with the left-hand point, and then I'm going to pick this point here as well, where the lines cross. So you can see that right angle triangle there. The distance up is 2, and the distance across is 2. So the gradient for this line is 2/2, which is 1. Okay, next we're going to go to this line here, which you can see is steeper than that line, so we would expect it to have a larger number, a number greater than 1. So again, pick 2 points. We're going to go, so that's across 1, up 2, and remember we do vertical, divide by horizontal, so that gradient is going to be 2/1, which is equal to 2. So that's a steeper gradient. It's a gradient of 2. Here it's shallower, so we would expect it to be less than 1 but greater than 0. A gradient of 0 is a horizontal line, yeah? So that's just a flat line going across. Okay, so again, from left to right, pick your left hand point. This will be important when we get onto the negative gradient next. So it's going across by 3 and up by 1, so the gradient is 1/3. We'll leave it as that. You could write it as 0.3 recurring if you wanted to. Okay, here we've got a couple of negative gradients, so let's look at this one. We can pick that point right at the top, and we can pick this point here. In fact, I'll show you all of them because this is a ratio. It doesn't matter how spaced apart the distance of the lines will be, it will give you the same number. So look, we're going down this time, so that has to be -3 because we're starting high and we're going down. This is a negative line, -3/1. So we know that our gradient is -3/1, which is -3. What happens if I pick this point and this point here? Okay, so this is going down by 6. So that's -6 over 2. -6/2 simplifies to -3. So we can see that it doesn't matter the distance apart because this is a ratio. Okay. Now the next one. Okay, so this is a shallower gradient, isn't it? I've got 1, 2. Remember that's a -1 because it's going down. So that's going to be -1/2 or -0.5. And then the last one, 1 across, and 1, 2, 3, 4, 5 up. So this is going to be 5/1. This is a very steep gradient. The gradient for the last one is 5. Okay, let's look at some actual lines now, and I'll show you how you can solve any of these equations, find any of these equations given that information. So remember, linear graphs, they're in the form y equals mx plus c. M is our gradient, so once we've found the gradient, we can just replace, substitute in that value for m. And c is the y-intercept. So this is the point at, essentially what we're doing with the y-intercept is we're saying, well, when x is 0, that c value will be equal to y, because anything times by 0 is 0. So it's a really easy way of finding a point on the line and also finding that information for the line. So once we know what c is, we will have already found the gradient. We can substitute that in, and that's given us the formula for the line. Okay, so example 1. I've got let's do the gradient first, and then we'll do the y-intercept. So here we go, look. There's a nice point here, and a nice point here. So we've got a vertical distance of 4. Now it's important, sometimes your axes won't actually be identical, so you really do need to measure that distance and make sure it's correct. Like 6 and 2, the difference is 4. Here 2 and 1, the difference is 1. So we've got a gradient of 4, so I can write y equals 4x plus c. Now where is the y-intercept? So we're going to go across to x is 0, so it's where does it cross the y-axis, this vertical line? It crosses at 0, -2. Now remember, the y-intercept x value will always be 0. So the equation of this line is y equals 4x, take away 2, subtract 2. Pretty straightforward. Okay, next example. So this is, you should already be looking at this and saying this is a negative gradient. So we know that it's going down, it's going to be y equals negative something x. So let's pick a couple of points. So there's a nice boundary here. There's also one here. So it's going from 7 to 4, so that's -3. And then across it's going -1 to 0, so that's 1. So it's going to be y equals -3x. Where's our y-intercept? 0, 4. So you can straight away go ahead and say y equals -3x plus 4. Really straightforward. Okay, thank you for watching.